going to have a look at 2014 C2 question 3. So I've got this triangle here. I'm going to draw it. I've drawn it out. First one is find the length of DB. So this is the first thing I'm going to find out. Then it's the angle ABD. So ABD is this angle in here. And then finally it's the area of the two triangles. So first of all, looking at this triangle, it's two sides and in between angle cosine rule. So x squared is 5.4 squared, add 4.9 squared, minus 2 times 5.4 times 4.9 times cosine 35. And when you're working this out in the calculator, do this bit first to give you 53.17. Then do this bit to give you 43.3495. So x squared, if you subtract them to 9.82047, and then square root that, so 3.13376 to three significant figures, 3.13 kilometers. Part 2 was finding this angle, so I'm going to use the sine rule. So 5.44 over sine, the opposite angle, equals the side. So I'll use this x, but I'll use it in its more accurate form, more decimal places, over sine 35. Fraction equals fraction, so cross multiply. 3.13376 times sine theta. Bring this across and it becomes a division. And you will be left with 0.988308 equals sine theta. So bring your sine across, inverse sine gives you a theta of 81.252585. So theta is 81.3 degrees. And the last bit of that question was finding the area. Area of ABC is a half the two sides times sine the angle between them, to give you an answer of 7.588. Area of the other triangle, BDC, is a half the two sides times sine this angle between them. So it's a half of the x, which is 3.13376 times 2.1 times sine the angle between them. To get the angle, it's 180 minus those two. So sine 180 minus 81.252585 minus 50. And that all works out to give you 2.473. And then the total area is those two added together. So the total is 7.588 plus 2.473 to give you 10.1 kilometers squared to three significant figures. We also have to do from this paper question 7. If I scroll down to get question 7, it's solve this equation. Otherwise, it's quite hard to see there. So 7a, you have 4 minus sine theta equals 6 cos squared theta. They're not the same words, so I'm going to rewrite cos squared using sine squared plus cos squared equals 1. So cos squared is 1 minus sine squared. So it's 6 instead of in cos squared, but in 1 minus sine squared. You've now got a quadratic equation, so times out that bracket. Everything on one side for quadratic, so 6 sine squared minus sine, and then 4 take away 6 is minus 2. You can use a formula or you can factorise. That factorises into 3 sine theta minus 2, 2 sine theta plus 1 equals 0. Put the first bracket equal to 0 to give you sine theta is 2/3. Put the second bracket equal to 0 to give you minus a half. Principal angle here, inverse sine 2/3 is 41.81. And principal angle here is inverse sine a half to give you 30. Cast diagram is running from 0 to 360. On this side, sine is positive, so it's these two. The principal angle from the horizontal. So your answer is 41.8 for the first angle, and the next one is 180 minus 41.8. And over on this side, 0, 98, 180, 270, 360, CAST. Sine is negative, so it's these two. Principal angles always horizontal. So your two answers here are 180 plus 30, and the other one is 360 minus 30, giving you a set of answers of 41.8 degrees, 136 degrees, 210 degrees, and 330 degrees. And part B of that question is quite a straightforward one. It's asking you to prove, that's quite hard to see there, so I'll just write it out. It's asking you to prove that tan theta plus 1 over tan theta is 1 over sine theta cos theta. So left hand side, tan theta is sine theta over cos theta plus 1 over sine theta cos theta. 1 over a fraction is the same as turning it upside down, so it's cos theta over sine theta. To add fractions, the bottoms need to be the same, so both those bottoms is cos theta, sine theta. This one needs an extra sine theta, so an extra sine theta on top makes it sine squared. This one needs an extra cos theta, an extra cos theta on top makes it cos squared. Sine squared plus cos squared equals 1. So you have now got the right hand side.